Hello, welcome to the SOLIDWORKS MBD webinar. My name is Gordon Purcell. I'm an application engineer at Desai Solutions, located in Phoenix, Arizona. Thank you for your interest in SOLIDWORKS MBD and our continued efforts to develop better design to manufacturing solutions. My intention today is to show you how SOLIDWORKS MBD can improve a process, such as speeding up how you define the product manufacturing information or the dimensional requirements for manufacturing. How SOLIDWORKS MBD can reduce some of the time it takes to create 2D drawings, as well as some of the mistakes associated with interpreting 2D drawings. How SOLIDWORKS MBD can publish technical data packages, such as 3D PDF and STEP 242, that have all the dimensional requirements directly on the 3D model. Something else to take away from this webinar will be how SOLIDWORKS MBD and DimExpert can speed up how you create 2D drawings today. So first, a little bit about why is SOLIDWORKS take such an initiative to develop SOLIDWORKS MBD, and why is ASME taking initiatives to develop standards. I think it comes down to, for some, 2D drawings are hard to understand and easy to misinterpret. So I came up with a couple of examples here to draw your attention, and this is a more artistic drawing, but it's a drawing nonetheless, and it's maybe the artist knows what it is, but it's open to interpretation here. I can't quite tell if this is a cow, a giraffe, aquatic animal, a land animal, the Loch Ness Monster. I really just don't know, so it leaves some interpretation here. And I think the same thing goes for drawings. Typically, these get printed out, and the scale may get distorted, and it's hard to, in more complicated drawings, hard to see where exactly where the dimensions go and the features we're trying to define. And that's where SOLIDWORKS MBD clarifies a lot of this. It takes a lot of the guesswork out. There's cross-highlighting between the actual features and the dimensions, and you can visually see the associated requirements for a feature. We also help support your compliance of ASME standards, Y14.41 and 14.5. They're kind of combined now. And we can also publish those to help you publish those technical data packages into universal formats such as a 3D PDF or a STEP 242. And just a little backstory here on ASME standards. First, we pushed out, not necessarily we, but ASME developed standards for Y14.5, and that's been considered, authoritative guideline for GD&T. What that does is establishes uniform practices for stating and interpreting the GD&T for the related requirements used on drawings. Then, as CAD has developed and people start to take more advantage of 3D CAD, people wanted to provide this same product manufacturing information inside of a 3D model. So ASME Y14.41 was developed, and that established the requirements for model-based definition. And both of these standards have been revised over the years, and ASME 1441 2012 was revised and basically encompasses all of these standards to allow the reader to find all the requirements in one location. And who is this for? It's been adopted by the DoD, medical and industry, automotive industry. It's basically any company that creates engineering, manufacturing, has inspection practices and utilizes 3D CAD. It allows you to, this model-based definition moves from something like this, where we have 2D drawings that include orthogonal views with dimensions, into a 3D model that defines the complete requirements and product manufacturing information. So how does MBD define PMI? And first, the MBD is model-based definition, PMI is product manufacturing information. Well, it leverages some technology inside of SOLIDWORKS. Every seat of SOLIDWORKS has some technology called DimExpert. And this DimExpert complies with the ASME standards for 1445. And when we apply that to a 3D model, it complies with 1441. So there's a couple of schemes here for dimensioning. There's auto dimension, which is my favorite, and I actually use some hybrid approaches where I typically define a certain amount of features, and then I'll re-auto dimension the next set of features, maybe in the right view, and then define features that would show in a top view. Um, kind of just translating that into how we traditionally create drawings. So you'll see me today go through multiple steps. I'll do auto dimensioning, I'll do manual dimensioning, I'll show you how to create GD&T control frames, datums, and then look at the model and see what's been fully defined and what needs further definition. How the technology works, it basically what it does is it does two things. It looks at the feature tree and looks at the feature and does a feature recognition on top of that. It can also use topology recognition, meaning so it can work on any imported parts or dumb geometry. First priority is the feature tree, second priority is topology recognition. So if I try to dimension this conical surface here and I select it with a size dimension, it'll recognize that as a boss typically, or a conical. There's all sorts of features, and the help file does a good job of listing all those. What helps you define and maybe override what the system sees as the feature is this feature scope selector. And as I'm making selections on the screen, maybe I select this face here and it defines it initially as a plane, but really I want a dimension that goes across the component. Then I could define that as a width type feature. So this is basically helps you capture your design intent and how you want to define your product for manufacturing. Keeping all these dimensions organized is critical, and SOLIDWORKS provides some really good tools. One of the tools we'll look at initially here is called Annotation Views, but it also provides another tool called 3D Views, which we'll get a little bit more in down the road. But the Annotation Views, just kind of look at those as basically they are always parallel to your standard views inside of SOLIDWORKS. But you can look at that as you compare those to drawing views. In drawing views, you might lay out the front view. In drawing views, then you create a projected view of the right view. Well, annotations are basically capturing the dimensions and notes that you would typically show in a drawing view. It helps. It keeps the clutter off the screen, and keeps the PMI organized. So let's jump over to SOLIDWORKS here. Here we have a part that I've already defined using DimExpert. Inside the DimExpert tree, we can see all the features that have been defined. I personally like to show this as the annotation view, and then I can see the dimensions that have been defined. I can see the datums, etc. And I can usually see the GD&T callouts, such as the concentric here. Now, underneath this annotations folder, this is where we have our annotation views. And you can right click on these and activate and reorient these, and it makes it really easy to see the annotations associated with that view. It also orients it, here to the standard view. I'm going to go ahead and hide this annotation here and just get that clutter off the screen. So this makes it easy to jump from one view here, where maybe we're trying to show some internal dimensions, to another view where we're showing external dimensions. As you can see here already, these views don't support things like section views, model break views, configurations. They're really just controlling the view orientation, and they're controlling what annotations are shown in that view. What MBD delivers are 3D views. Now 3D views control lots of things. They can control which annotation should be used. So I can jump from this one notes view to the other view. And here we can jump down. We can jump down to the front view. And again, I can capture another front section view here, so this view remembers that it's a section. Jumping to this view, this view remembers that I set up a break view and shows all the foreshortened dimensions. Now, it may not be necessary here, but when we get into larger assemblies or welded structures, this is going to be very beneficial to you. Another benefit here is the cross highlighting. So if I jump back to this view and we pick a dimensions, it's very clear the features and surfaces that this dimension is associated with. Right? So that's very beneficial. And then in your organization, if you're not translating data, you may be using SOLIDWORKS. You could easily just open SOLIDWORKS and navigate these views on the shop floor and pull off the dimension requirements. So we have all this nice cross-highlighting here. But something else we can deliver to MBD is a universal format. We can take the same model-based definition that has this cross-highlighting feature and publish it out to a 3D PDF. And this is going to be very important for the MIL standard 3100 ACE compliance. And we can create a complete package. We can also attach things like the Step 242 file here or other specifications and requirements for the technical data package. So we have the same thing here. What MBD is creates the views inside of the 3D PDF, and it makes it very easy to navigate through all of the requirements. And you can create as many of these views as you need. You know, typically I would break these down maybe by operation or by step, maybe internal features, external features, by configurations, operations, that sort of thing. And here again, we can see we have the same cross-highlighting support. Select the dimension and the feature highlights. Some other benefits are these are just not 2D, they're actually 3D, so it's easy to navigate and rotate within the part and get a better idea of what the feature looks like. For those Adobe Power users, you can still use things like the toolbars up here where you can use measure. You can actually jump to your views from the pull down menus as well. Over in the configuration tree, for those really interested, you can see all the dimensions in the tree here. So I want to give you one more example here before we get into the demo. So here's another example where we have some notes in here. The views are on the bottom. So we have a template editor, and we have a lot of templates out of the box that you could use. You can modify those to develop your own style, put your own background images and company logos on those as well. And then here, I just wanted to show this one because we have full support for GD&T, the GD&T and ASME 14.41. And we have the same cross-highlighting. You see I can pick on the feature in the associated holes and features are highlighting. And then another benefit here of using something like a 3D PDF is you can use the measuring tools. So inside of Adobe, we have a bunch of snap controls. We have measuring type filters. And here we can just pick up on this radial edge and another radial edge, and we can measure the component. It's getting more and more common where people are doing partial or just defining CTFs, but for manufacturing, they may need to grab a couple other critical dimensions on the shop floor for those specific operations, and this provides those tools for them in a universal format. Pretty much everybody has Adobe Reader installed. Getting back into the next part of the demonstration, I have three components I want to go through. There's basically a couple of parts that are lathe turned and a couple of parts that are typically milled type operations. And in these demonstrations, I want to show different dimensioning techniques, which are fully automated, some that are could be manual, some that could be a hybrid of both, etc. So the first example here is this milled part. And I'm going to use a traditional plus minus dimensioning scheme here. And this is still pretty common today for those that have in-house manufacturing. We can also see there's some patterning in here. So when we get into this auto dimensioning tool here, we're going to specify that this is a prismatic mill type part. We'll use a plus minus scheme, and the patterning dimensioning scheme will be linear. And one last thing on these templates. This is where you want to spend some time ahead. You want to go into your document properties and up to DIM Expert. This is where you want to define your block, your standard. I'm going to use the ANSI standard here and your general block tolerances. This can be really beneficial, right? This can save a lot of time. I don't want to dimension everything that has a tolerance on it. Some things are just going to be, if it's a 2-place decimal, then it should use this block tolerance. If it's 3 plays, then it should use plus or minus 5. Typically that's found in a drawing's title block. So I'm really reproducing the same thing here. Then when I get into the size dimensions, I can specify, if it's a diameter, should it use a symmetrical, a bilateral, or should it use the block tolerance? And should diameters default to use a 3-place decimal block tolerance? I'm going to leave this at symmetrical. Same thing for location, things that distance dimensions, angular dimensions. Do I want them to use a symmetrical tolerance or do I want it to use a block tolerance? For holes, just like this illustrates here, do we want our holes to be defined as chain or baseline schemes? Same thing for the pocket dimensions. These are more specific to the geometric intolerancing. Do you want to create basic dimensions automatically? Should they be chain? Should they be baseline? Etc. And then some various display styles. How do you want the datums to be, and the datum control frames to be associated with the dimensions? So it's really important to get in there and spend some time and dial in those settings. Let's go through our first part here. I'm going to start using the auto dimension scheme, which is really powerful. It's basically going to look at the model and extract all the dimensional data. We'll set the part type to prismatic, and we'll use a plus or minus scheme here. Again, because my holes are more in a linear scheme, this first auto dimension scheme will just recognize those as linear patterns and use the appropriate baseline or chain dimensioning scheme. Now when I define the datum references here, I'm going to kind of think about how this part is mated into place. Typically this part would be mounted back on the back surface, so that'll be my primary datum. And then it may be located by one of these holes, so I could specify a hole to locate it. In this case, what I'm going to do, I want to show you a wide variety and flexibility here. I'm going to use a plane to define the location. And then for the tertiary, for the orientation, I'm going to do the same thing. Here again, I'm going to use a datum plane. And this is where it gets interesting and fun. All right, for the feature scope, what do I want to do here? What do I want to actually extract as far as manufacturing requirements? Well, I can leave it on features, selected features, and just individually extract features that I want to mention. In this case, I want to just extract all features in one step. I want to show you how fast this can really extract and define everything. But in the event I didn't want to maybe extract the holes or specific features, I could unselect those. And I'm going to give you another example of how beneficial this is in the next exercise here. So we're just going to leave the filters to define all features. And we'll go ahead and hit OK. Now this is going to put a lot of definition on the part. We're going to need to spend a little bit of time cleaning up the dimensions just like we would in a traditional drawing. And we have all the same tools here. We can move the annotations around. I'm going to go ahead and put the holes on the right here and on the top. And you'll see why in a minute as I go through and clean these up. We'll leave the slots and the pockets on the bottom side. And here I recognize, like I said, it was going to recognize these holes as a pattern. These are actually just drilled holes, and then these are tapped holes. Maybe I want to drag this annotation up top here, but that's no problem. It's just like it would work in a drawing. We can just grab the end of the leader and move it to another feature, and then put the annotation where we'd like it to be displayed. Same thing with radii, really any dimension. For now, we'll leave that where it's at. Same thing with the arrowheads. If you want to flip the direction of the arrowhead, just like you would in a drawing. Nice and easy. Now, what I might want to explain here, take a second. What happened is I was in this annotation, this top annotation view when I created these dimensions. So all of the dimensions that are normal to that face were automatically by SOLIDWORKS placed in the annotation view. And if I go and orientate the the front view, I'm going to see the thickness of it, right? Most of the dimensions in this part, it's more or less a 2D profile, but we do still have a thickness. So it does organize the dimensions well and lays those out automatically into these annotation views. I'm going to go back to the top view. What I might also do is have additional annotation views to organize specific features or specific operations. That's one thing I like to do. So I can move these into another annotation view. I'm just going to hold down Control and select all these holes. We can just use the tilde key and we can move these over to another annotation view. So we'll spend a few more seconds here cleaning up our dimensions. And it's starting to look pretty good. Right? And again, if you wanted this pocket or these slots to be different operations, easy enough. Just go ahead and move those into their own annotation views. Okay, so let's just jump over to our tapped holes annotation view, and we'll just basically do the same thing. We'll organize everything like we'd like it to be viewed by the operator. There we go. So now what we have is a couple of views. One that shows operations for the holes, one that shows operations for the slots, the pockets, and the overall profile of the plate. Again, as if we need to do further organization of the models, maybe I'll even be a little bit picky. Maybe I'll drag this up to the top here, just to show you we can do that. Right now, it makes it really easy. I can just jump back and forth from this view to my tapped holes if I need to make any adjustments. Now, you may also want to add some notes. So SOLIDWORKS has always had this annotation view here with the notes area. And this is beneficial if you want to put a watermark in the background or you just want to put in general notes for plating. So rather than really you just use a note and place a note in here. But I want to keep things rolling along here. So what I have, I'm going to jump over to my design library. Go to my annotations folder. I'm just going to drag a note that I have already defined right on the sheet. And what's really nice about these annotation or these notes, annotation views that are in this notes folder, they always keep the notes normal to the screen, so they don't rotate like the dimensions. Just move that over there. Great. So now what I can do is, again, I can toggle back to these annotation views, but another way to start to consume this data and prep it to be published out to a 3D PDF, what I would start doing is I would start capturing these 3D views here. And in these 3D views, there'll be more to come on configuration display state. They do just a lot more than capturing the view orientation and what annotation should be viewed. Here I just want to tell it to use the notes area for the annotations to display. We'll go through and we'll capture our next 3D view. Now, at this point, we might be ready to publish this out to a 3D PDF. One other thing I like to do is sometimes I'll create new annotation views. So I'm going to insert a new notes area here. Just use F2 and I'll call this a watermark. Alright, so maybe we want to put something in here. Maybe this is only ready for quotation. We're going to send this out to vendors. Probably should have used all caps there since this is really important, but let's make this red and let's make the size, the font a little larger, and we can make it bold. And so again, this is a note. It's going to stay normal to the screen, and it typically shows over top the model, which is fine. But if you want to, you can also make this a watermark. And really what that does when you pick on the notes, it gives you a couple group boxes down here where you can say it's always behind the geometry or on top of the geometry, but you want to make that watermark transparent. Cool. Now a couple of things. What could we do next? We could publish this out as our 3DF. We can export a step 242 file. Let's just show you a glance at how to produce this step 42. What I'm going to do is, or the 3D PDF, what I'm going to do is include the notes area and these 3D views that I've captured down here. So we'll just select those. We'll pick our template. And down here we can check a box to create and attach a Step 242 file. We'll hit Next. Here we can map all the information from the custom properties inside of SOLIDWORKS directly to the 3D PDF form field. So we'll map the part number on the PDF form field to our part number, revision to revision, the material, and if we had comments, you can also have text input box here. So I'll just go ahead and write my name over here. Again, completely customizable. You can add whatever form fields that are part of your company standards. I'm going to spend more time on how using DimExpert and how to define the dimensional requirements today, as opposed in a little bit less time on actually creating and publishing the 3D PDFs. But real quickly here, I just want to show you how that works. Again, you can have notes fields in here. We can add critical notes. All right. Again, if somebody wanted to open this 3D PDF at this point, they could measure, or they could add 3D comments on here and save it with that PDF. I also wanted to show you another advantage of using DimExpert. You can take all this technology and save all this time to start to develop model-based definition practices, but there's going to be times you still need to just create a drawing. And I want to show you how quickly you can create the drawings with the same definition produced in the model on a 2D drawing sheet. Let's jump back over to SOLIDWORKS, and we'll create a new drawing view. Right, so we have these drawing views over here, and if you didn't know, A represents that view is an annotation view, meaning it has dimensions or annotations associated with it. And we can import the DimExpert annotations when we drag and drop these views. So I created a bunch of dimensions on the top view, so we'll go ahead and drag that in there. And I picked an ANSI standard, and I want to just change that to, or excuse me, I picked an ISO standard, so I want to change that over to an ANSI standard to get a better look and feel, or a familiar look and feel, right? So here I was able to, again, leverage everything I did at the 3D model and create a 2D drawing view very quickly and effectively. I could spend more time cleaning that up, but I think you know how easy that is to do with SOLIDWORKS already. Great. So what I might do is I might have another sheet here, and we can really just repeat the process. I have another annotation view for the tap tools. But again, what's nice about this is all the definition really is done in the model, right? So it's all coming from one source, and the model essentially of our virtual gauge that we can go from design to manufacturing. But if we need these 2D drawings, we can have these 2D drawings. If the model changes, the drawings will update to match the model. And let's go through our next example, which is an auto dimensioning scheme for GD&T to support the ASME standards. Here again, I'm just going to use a prismatic for a milled type part and geometric. This time I'm going to be more specific on how I select my datums. I'm actually going to use width features or geometry to define the center of the part, as opposed to using datum planes. And what's going to be different here is I'm going to go through multiple steps using auto dimension. I'm going to just define the general layout of the profile, the slots and the pockets in the first auto dimension step, and in the second auto dimension step I'm going to switch to a new annotation view and define all of the holes. As in the previous example, I just kind of did everything in one step and then moved the annotations around. Here I'm just going to show you how to just lay out dimensions and define the dimensions in 2 steps using the auto dimension tool. The first thing here is we want to make sure we use our prismatic, and we want to change this to geometric and tolerancing. And again, our hole pattern is still in a linear fashion. We want to define these datums. It's going to be the plate will be placed on this face. Now I'm just going to pick up the theoretical midplane of this part for the secondary and tertiary datums. I'm going to select this plane here, and that could just be a datum for our secondary, and then I could move down and just use this plane as our tertiary. But again, I just want to pick up the center of the plate. So what I'm going to do is just go back, highlight my secondary plane, pick this plane again, and now I'm going to use my feature selector up here to change this to a width feature. And this is really helpful anytime you are doing like draft or intersection points or curves, or using width features. This allows you to make multiple selections. There we go. So you can see both planes are highlighted, and that defines the center, the mid plane as the datum. And you can see that it recognizes that as a width feature over here in the datum. And let's go ahead and repeat that for the tertiary plane. Great. Now, I find this particularly interesting and helpful. These are the types of features that DIM Expert will define. And in this case, I know these are created with Hole Wizard, so I know those will be recognized as a simple hole. So I'll just go ahead and uncheck that. Everything will get automatically defined for ASME 14.41 and accept those holes, and then I'll come back in a secondary step and define those holes. So green, the tolerance status, green means that everything is fully defined. And it did everything that I wanted. All the radii, the profiles, the pockets, and the slots are all fully defined in a couple of clicks. And what's left is there's no definition on the tapped holes in these holes here. Again, I may want to move these around. You have a lot of flexibility with how you want to display the datums, whether attached to the dimension or whether they're attached to the control frames, the property managers, how those are controlled. So let's jump down to our annotation views. Let's go ahead and hide our dimensions, and I already have these tap views set up, the annotation set up. What I'll do is I'll actually show you how I create this tapped holes annotation view. We'll delete the one I have here. Right, so we'll just go insert an annotation view, and my orientation will be parallel to the top. Boom. This is really nice here. This just allows me to kind of pick annotations right on the screen and move them right into this new annotation view without having to go back and move things around later. But we're just going to create this with no annotations in it. And I like to just name these so it's very clear what operations or what the use case is for this annotation view. And we'll just go back into annotation view. Before I do that, what I like to do is show the datums, right? So actually I'm going to go back and show the front view as well, so I can clearly see datum A, B, and C. And this makes it really easy to repick my existing datums if needed. So we'll pick A. And these are some new features that have been developed in the 2016 or 17 release, able to reuse the datums. And I don't want C as my secondary, I want B. Another thing is if you didn't have the datum showed, you could still just come up here and pick the face, and it remembers that face is associated with datum C. So that makes it pretty easy. And now, as opposed to I could have two options. I could unselect everything here and go back and just check simple hole. But to show you how the selected features, the scope of selected feature works, I'm just going to go ahead and pick the tapped holes. Again, it recognizes these as a pattern. We can see that on the feature selector and down here. And we'll hit OK. Right, so if we hide the annotations associated with the top view, we can clearly see all the annotations, the true positions have been defined for the holes and the tapped holes. A couple of neat things here. If I go back to my top view, basic dimensions. That's something that's done in your template, whether you want to see basic dimensions or not. And on my template, I have those turned off. Because right here, create basic dimensions, whether they're chain or baseline. A couple shortcuts to go back and add that. One We can look at our dim expert tree here. I'm going to find my true position callouts, and I can just say recreate basic dimensions. You can also, we have to show some of the advancements in technology. We now can manually create the basic location dimensions for size and location. And what makes this nice is we now all support selecting edges. Again, I could just pick my datum reference here, and it knows that the datum is on the center of the part. And so on, and associates that datum with the axes of the hole. Okay, so that wraps up that example here, where I was trying to show how we can automatically dimension things, a GD&T scheme per ASME 14.41 or 14.5, and really speed up that whole process and make that process uniform for how the GD&T is defined and how that's interpreted. This last example is probably my favorite. It's a lathe-turned example where I'm going to show you how to use some of the automatic dimensioning schemes for GD&T dimensioning, but also how to manually create some GD and control frames, manipulate control frames, how MBD can support section views. Like, this is really important, right? The other parts were pretty straightforward. And this part here is more complicated. We need to clearly illustrate internal features versus external features. So for that, we can use a section view. I want to show you how MBD supports section views, and also model break views when views or assemblies get very large. Sometimes we want to create break views, and MBD has a good way to support that. We also support configurations. We might have a long version or a short version of this part. We might have various display states for our work instructions where we want to show masking or plating should be specified, so I can use different appearances and colors for plating callouts. So those are just some of the additional things that we can support with MBD. Okay, so here in our lathe turn part, you can see that we have a default and we have a long version. We also have a couple display states. If you're new to display states, these are actually they're the same right now, but display states, just remember display style, whether it's silhouette, shaded with edges, or colors, mappings to bodies, faces, parts, etc. Okay, so for defining the internal features, it's nice to get into a section view, and we'll go over to our auto dimension scheme here, and this time we'll change this to turned. And the difference is I could make this prismatic but turned, but with turned with GD&T, it's going to follow the ASME standards, and it'll define all the circular runouts automatically for me, so I don't have to manually go back and add those control frames. And we have up to 3 datums again, so we can select our primary and our secondary datums in this case. And then this example here, this is probably the most common practice of how I use MBD. I use the selected features. And I'm going to go ahead and just pick some of these internal cylindrical faces. What also I think is, from my experience, is something like this O-ring or this groove is much easier to define on the using a section view as well. So let's go ahead and grab these faces here for these grooves. And we'll hit OK. And like I said, we have our dimensions now defined based on our template, along with the circular runout. There's actually, it looks like the dimension here for the datum is probably in a diametral view. So let's go ahead and take a look at this. Turn that off, or change it to diametral. And it probably got placed in another view, so I'm just going to go ahead and show the rest of these views. Just shift select there. And there it is. All right, so here we have our dimension, and I'm going to go back now and change that so that it's shown as a linear dimension as opposed to a radial dimension, and that it's parallel to the axis. Okay, and you have the flexibility to kind of lay that out as needed. But what I'm trying to do is I'm trying to communicate how beneficial MBD can be for something that's where we're trying to define internal or external or something that might be more complicated. And again, here we can see that cross highlighting. And I have annotation views set up for all my to illustrate my requirements. But now what I'll do is I'll create 3D views. And that's going to remember that my model is in a section mode. So for this, we'll just capture our front section, and still in our default display state and configuration. Cool. Now as I jump down to my front view, I may want to start to illustrate the outside cylindrical profiles. So we'll just go through another auto dimensioning scheme. Reuse datum A, datum B, and select our external profiles. Great. Which is going to capture the requirements for the external associated with our front annotation view. Then the next thing I want to show is, well, what about configurations? I have a long configuration and a short configuration here. Right, so if I just jump over to my long configuration, we have the option to copy a scheme. So I can just copy the scheme and pick another configuration. I can pick my default configuration as the source scheme and copy that right into my long configuration. That's pretty nice. So then again, I would create 3D views here based on my long and short configuration. So now the long is going to be selected. So we'll call this long outside diameters. Right? And again, it transferred this information directly over to the annotation views found in the front view and in the front section views. Again, I just want to create my section here. Create another 3D view for the long version. Okay, so what about display states, or what about trying to illustrate and communicate where we might need masking or where plating should be specified? For something like that, I would do additional supporting notes and maybe even consider doing using display states. So let's jump down to our plating display state here. What I might have is another annotation view now for plating, just as an idea. So I'll create another front view annotation view. And we'll just rename this plating. Again, what's unique about this is where the notes will be associated with. So we can go ahead and hide these now. And we'll just go over to our appearances task pane here, and we'll grab a color. Just going to grab any color. Blue's nice. And we'll apply that color directly to that face. So now we can have a note. Say, I don't know, we'll say nickel. Something like that. And we only need one of those, so what we'll do now is we'll just use a leader type on that, and we'll just drag the leader right onto that face and capture our annotation view. Again, it captures our configuration and our display state. And it's easy to kind of go through, look at all of our dimensional requirements, our various configurations for the long, the short version. It's very easy to see the internal, external requirements. And we even have a configuration here for controls the display state and where the plating is allowed. And one more thing I wanted to show you, which is kind of nice about MBD. So when you get with longer parts or welded or structures or maybe even assemblies, we can create model break views, and that's also supported inside of MBD. And these are kind of neat. There's a bunch of different styles in here. So if you want to have the traditional break looks, different methods, then there's a sensitivity slider down here. There's different visual support options there for you. And that converts all the dimensions over to foreshortened. And again, we can capture another view here, and we can call this broke view. Great. And then when we're done with everything, again, we've already kind of went through this once, but I'll just show you how this finished product looks inside of a 3D PDF. I'm going to wrap things up. So in the end, the 3D views support configuration, display state, section views, model break views, exploded views, display styles. In the end, if you need some supporting drawings, you can still leverage all the DIM Expert technology to create those drawings. I hope you got out of this that you can see that you can kind of speed up everything by directly working in 3D with the PMI, support the ASME standards. This will reduce some of how those drawings are created, give you more consistency, improve the consistency with how they're interpreted, and how you can create these technical data packages with 3D PDFs, Step 242s, as well as just maybe doing something a little bit different, a little bit better today, is just taking this DIM Expert technology and creating 2D drawings. And we'll leave you again with, before I take your questions, that sometimes 2D drawings are hard to understand and easy to misinterpret. And the same applies for engineering drawings. And it's a few suggestions here to kind of where to go. Use DIM Expert, create some drawings in your next project. Start using annotations to organize those the DIM Expert annotations. Go to mysolidworks.com. There's lots of training there that'll get you really familiar with DIM Expert as well as MBD. Contact Decide Solutions. Let us know if you're interested in evaluating MBD or you just want us to come out and talk and see if it's going to work for you. MBD features shown today were really the 3D views, the model break views, and how it supports sectioning views, exporting all the PMI to 3D PDF, Step 42s, and support for the mill standard 3100A technical data packages.